Now you want to connect to the IPv6 internet. There are different options. The two major types of internet connections are native connections, which means you have direct IPv6 connectivity to the IPv6 internet. You have an ISP router, and the ISP router has IPv6 inside and outside, and you have your own prefix. And then there is tunneled connections, which means IPv6 is tunneled over IPv4, and the IPv6 routing is reliant on the IPv4 routing. So if IPv4 fails, if IPv4 behaves bad, your IPv6 is also broken. There is no direct end-to-end IPv6 connectivity with the tunneled connection. You have to prefer native connection. So ask your provider if you can get a native IPv6 connection with a real IP address. The first option is native IPv6 connectivity via your ISP, where you have an IPv6 address or a whole IPv6 prefix out of the PA space of your upstream ISP. PA means provider assigned. Your provider has been allocated this space out of the RIR or LIR pool, and it can use it for their customers. You have an IPv6 address or prefix. You're single-homed, which means you have only one internet connection. In this case, you have your private network and you have a default route to the ISP. The ISP has a static route towards your network back to you. This is the easiest setup, and this is the first native connection. The second option is the same thing. You get IPv6 addresses out of the PA space of the provider, so it's not your own space, but it's the provider space, and you are dual homed in this case, which means you have two connections, you have more redundancy. Option A, you have two connections between the same routers. Redundancy is a bit higher in case the cable fails, the SFP fails, something, but if the router fails, you're still down. In option B, you have two routers, the ISP has two routers, and both your routers have default routes to the outside, and both ISP routers have static routes towards your network. In case a cable fails or a router fails, no matter which one, you will still be online. This is a good type of connection. Option 3, you have your own PI space. PI means provider independent. It means you have asked your provider to get your own prefix that belongs to you, or you have talked to the RIR yourself and got your own PI space. This space belongs to you, and this space can be announced by the provider. In this case, routing is the same. You route default to the provider, and the provider routes static towards your router, routing the prefix you own. The provider router then announces this prefix to the internet using BGP. The better version, you run BGP between your routers and the ISP's routers. This means you can announce your own PI space prefix to the ISP's router. The ISP's router will forward this prefix to the internet. So this is your upstream. You have your own prefix and you can control whatever you do with it. You can switch path from the backup to the primary anytime you like, and you don't have to talk to the ISP for that. So if you do maintenance on your router A, you can just switch the routing path to the router B anytime you like. The good thing about PI space is that you can change providers and you can keep your addresses. In the other cases where you use provider aggregated space, PA, you have to stay within this provider to keep this address. If you change to another one, you get another address. You have to renumber everything, your whole network maybe, or at least all of your servers. Let's have a look at the tunneled options. I told you before, the tunnel broker are not for production use. This is just for testing. This is no native connection and not recommended for live deployment. But in this case, just as an example, you can create an account with 6access. Go to the link 6access.net/signup. After your account has been enabled, you can apply for a tunnel. You have to write why you need the tunnel. You just want to test drive IPv6 and then you will enable it. Then you can choose what tunnel type. Choose the appropriate one depending on your connection. And on the second page, you can choose your nearest POP, which means your nearest breakout point where the tunnel ends and where your packets are sent to the real IPv6 internet. If you choose the nearest POP, you will get the lowest latency.